Hi everyone, we're going to wait another minute or two just to allow everyone else to join in. So in a minute or two, we're going to go ahead and get started. All right, we'll go ahead and get started. Hello everyone, I am Jeff Suda with the Steel Utility Pole Coalition, and you are attending the Stay at Home series, a free 6-part webinar series on how to build a better distribution and sub-transmission with steel utility poles. Today's topic is Steel Poles 102, Energized Linework and Safety, and is presented by Tony Boyd and Jim Vaughn of the Institute of Safety and Powerline Construction. If your audio is not clear or you prefer to have your audio come through via a phone, you can find the dial-in number by clicking the event board icon at the top right corner of your screen. A drop-down menu will appear with the dial-in and a PIN number for this presentation. If you have any other technical difficulties, please ask them in the chat feature at the right of the screen. During this presentation, if you have any questions, please use the chat function on the right of your screen as well. After this presentation, later today, you will receive a link to a Dropbox folder that contains all of these slides for this presentation, as well as a quick survey. If you could fill out that survey, that really helps us in improving these webinar series in the future. As I had mentioned, this is the Stay at Home series, a free 6-part webinar series on how to build a better transmission and distribution and sub-transmission system with steel utility poles. This webinar series is held every Thursday from 11 a.m. to noon, and today's topic is Steel Poles 102, Energized Linework and Safety. Future topics include distribution steel poles and design and engineering on May 7th, durability solutions and inspection of steel poles on May 14th, steel pole case studies, what has worked for other users on May 21st, and we will wrap up this webinar series with a steel pole Q&A with a panel of experts where we will recap all of the questions asked during this presentation, as well as open it up for audience questions and discussions. I'll try and speak a little louder. I'm seeing that someone can't hear me, so if a large group can't, please type it and I'll try and speak a little louder. So in last week's webinar, I gave a more in-depth introduction of the coalition, giving people ideas of who we are and what we were trying to accomplish. For this week, I decided I would give a very brief introduction for those who did not attend last week's presentation. So the Steel Utility Coalition is a coalition of industry groups, manufacturers, and end users whose goal is to promote steel poles for use in distribution and sub-transmission through education, research, and marketing. Last week, I got some feedback that there was some confusion as far as dues or fees for the coalition, so I want to be a little bit more clear and go over that. For all members who do not see a commercial benefit in increasing the use of steel utility poles, such as utilities, individual linemen, educators, instructors, contractors, or consultants, there is no fees at all, and all education resources and other resources we develop are completely free for you. For members who do see a commercial benefit in the increase in use of steel poles, sorry, it just looks like you can't really hear me that well, so I'll try and move a little closer to the mic. So for all those who do see a commercial benefit, there is a yearly due that helps support the efforts of the coalition. Last week, I invited everyone who is interested to join the coalition in our next meeting on October 12th in Hartford, Connecticut. This meeting is being held in conjunction with the American Galvanized Association's Tech Forum, The coalition holds 2 meetings in person per year that coincide with 1 with the utility show and 2 with other industries we partner with shows such as galvanizing, steel, or other industries. If you're interested in joining, my contact information is in the chat feature on the right. If you'd like to get more information, you can visit our website or reach out to me directly. For today's presentation, our presenters are Tony Boyd and Jim Vaughn with the Institute for Safety in Powerline Construction. To give you a little more background on our presenters, I'll go ahead and introduce them. So Tony Boyd's career spans over 40 years in electric utility industry. Tony has specialized in the technical side of business with extensive experience in transmission, overhead distribution, and underground distribution systems. Tony's experience includes the safety and training side of electric utilities business, focusing on best practices in the industry and concentrating on promoting safety in every aspect of his work. Jim Vaughn is a senior consultant with ISPC. As a senior consultant for ISPC, Jim serves utilities as a safety specialist in utility industry-related OSHA and consensus standard. Jim provides both consult and program development for utilities and OSHA-compliant policies and procedures, as well as consult on incident investigation and incident-related litigation. Jim also develops and delivers ISPC trainings as well as dedicated client-specific training programs. So I'm going to go ahead and hand it over to Jim and Tony.
All right. Good morning, everybody. And Tony's going to run the slides. I wanted you to know that I, as 47 years in the industry, my first 25 years was with the utility, and then about 10 or 15 years as a contractor also. So we'll also be addressing, as Tony goes through the slides, I'll pop in once in a while and we'll talk about some of the things contractors do in order to work around steel poles, some of the peculiarities, some of the changes that have happened over the industry as more steel poles have come into practice, especially in setting poles in hot or energized environments, and some of the things that we have done as industries in the field in order to improve or maximize safety during these installations. So thank you for being here, and thank you for allowing us to work with you. Tony, take over.
All right, thank you, Jim. I'm kind of the opposite of Jim. I actually started off in the contractor world and then got with the utility, doing transmission, overhead, underground, and over 40 years. So basically what we're saying is we're old. We do focus on safety, and ISPC does offer customized training for any kind of situation that you might have involving the utility. We customize a lot of training and have done it lately for telecommunication folks that are realizing they have the electrical hazards that the electric linemen have. If you were with us 2 weeks ago, I know Jeff said last week y'all had the NASCC, I think, steel conference. So we missed you last week. 2 weeks ago, we kind of introduced just some of the practical working with steel poles, drilling holes, setting poles, things like that. This week, we wanted to just really focus on working in the energized atmosphere. So you utility guys that have joined us, welcome. And, if you have any questions, feel free to type them in, and Jeff will make sure that we get them and we can get those questions answered for you. To get started, a couple of slides that I showed last time, just wanted to re-emphasize the difference between wood poles and steel poles. Steel offers a little bit better conductivity than wood does. This was a test that was done in Nebraska. We have a Southern Pine 40-foot CCA treated pole that we suspended from 2 digger derrick trucks. We put lag bolts, lag screws in each end, and on the top, we actually energized it with, let me find my slide, 7,600 volts. All right, so we backfed through a transformer and we energized the top of the pole. 7,600 volts. And to no one's surprise, we got 6,900 volts at the bottom of the pole. Oh, wait a minute, everybody says, that's wood. Back in 2002, I actually was part of another test with Mississippi Power. And they had a pole yard that they created an insulated area. And we actually tested a 30-year, 40-foot creosote pole. It had been in the ground for 30 years. And the only reason they replaced it, it was not rotten. The only reason they replaced it is they needed a taller pole there. So when they brought it in, some of the engineers said, hey, let's test it and see if we got any conductivity to it. I was unable to get any of the references that we had for that. But what I do remember is we energized the top of the pole, 7,600 volts. And at the bottom of the pole, we measured a little over 300, maybe 300.2 volts. And that's on a 30-year used wooden southern pine creosote pole. So for all the line workers out there that may be listening, or you may be talking to, that was always under the assumption that wood was a little bit of an insulation and they didn't have to worry about it. All this time in the industry, you were wrong.
And here's where I want to add in for both linemen and for the pole manufacturers. Over the years, I know that manufacturers go out and talk with utilities, and utilities say, well, we don't want to use steel poles because they're more conductive and we won't have the BIL that we get from a wood pole. Linemen, on the other hand, think that wood, as Tony alluded to, think on the other hand that wood poles are safer to work with because they are non-conductive. And when we first introduced steel poles into the distribution or transmission industry, we had a lot of feedback with almost all linemen the first time they think about it, is that they're concerned about the possibility of a flash because they think that the steel poles are more dangerous to work with than wood. So I think that the takeaway here that you should see is by voltage comes along with OSHA's expectation that it doesn't matter if it's wood or steel. They're all supposed to be considered as conductive. They're all supposed to have covers in place or insulation and isolation in place when we work energized at the top of a pole. And there is no validity to the argument on either side. So steel pole manufacturers, when you're looking to sell or promote your product into the industry, need to be aware that this is the case, that wood poles are not more safer to work with than steel poles. And linemen and contractors and utilities on the construction and maintenance side need to understand that there should be, as far as they're concerned, no difference between the two. And like Tony points out, every pole is different, and it depends on the environment that it's been in, how dry the wood is. Because I used to do the same thing on a 4 kV feeder, 4,000 volt feeder. If we had to change out an insulator, we would just take the conductor, untie it, and lay it right on the wood arm. And if it smoked, you just lift it up and put a leather glove under it. And that's how we treated it. And that is an error in judgment. It still should be covered, and we should not be taking anything for granted. Linemen are pretty familiar with the fact that when you're untying and you're taking control of the thin tie wires that tie the conductor to the insulator, they control it so that it won't hit anything as they're unwrapping that long piece of copper wire or that long piece of aluminum wire. But they also know that if they accidentally do strike a cross arm, it's just going to smoke a little bit. It might pop a little bit. And when they get out the steel arms and steel poles, they treat that differently. And that's a mistake. All poles, arms, everything should be treated exactly the same. Cover up, everything should be considered as a difference in potential and covered and isolated in order to keep from contact. Go ahead, Tony.
Thank you, Jim. Talking about grounding the poles, threaded inserts, grounding nuts can be placed anywhere along the pole where the grounding attachment needs to be made, for instance, at the system neutral. And then at the bottom, the bottom of the pole has a protective coating on it. So it does not typically make good contact with the soil. So an added ground rod would need to be used. Uh, I think I got a question one time a long time ago about leaving the coating off of the bottom of the pole, and that's between you and the manufacturer. You know, I think I would rather have that coating on the bottom to protect the bottom of the pole and run an exterior ground. So it's up to the user how you want to do it. But we take a wooden pole and we run a copper ground rod down and staple it to the pole all the way down the pole. So using the pole as a ground uh, continuity, then we don't have to use as much copper. So there you've saved a little bit of money.
And here
Uh,
also, from the perspective of galvanic series for you pole engineers, when you have nickel galvanizing in the ground next to a copper ground rod, if the moisture is present to create the galvanic series, what happens is that the galvanized begins to eat away, which exposes the underlying steel and results in a failure, over time. So there is a consideration there about what kind of ground rod is used and how far away you should place the ground rod from the pole. And that might take a little bit of research or concern, and maybe even
mhm.
periodically, utilities should probably do some excavation at the foot of a pole once they go into steel and start to look to see if there is any deterioration of the coatings or deterioration of the steel. Coating with that dielectric corrosion protection eliminates that possibility. And then the other is the Core 10. As far as I know, Core 10 poles have had very little reaction with copper that's in the ground. There's one other reaction issue, and that's if older gas line systems that had galvanic protection using those series DC currents or negative current in order to protect the steel pipe. Over the years, we've always had trouble with those old gas lines, those old steel gas lines, eating
Yeah.
galvanized anchor rods right into it'll actually create a penciling of the rod until it fails. So well, the same thing would happen to a steel pole. So those are the kind of concerns that you need to bring to your clients if you're selling steel poles, and clients who buy steel poles need to understand that that is also an issue. Most engineers are pretty good at that as far as utilities are concerned, but it may not occur to them right away. And all across the country, the galvanic reaction is going to be different according to whatever metallic properties there are in the ground and the amount of moisture that's going to be there. Go ahead, Tony. Thanks.
Thank you, Jim. So it depends on where you're going to put the pole. Uh, the next slide here, maybe. Yes. Getting into working in that energized environment, the amount of necessary cover gear always depends on the job that you're doing. Um, I remember when I went from contractor to the utility, it was a bit of a transition. I got to the utility and we were going to change out some cross arms. So I asked for some rubber goods. And first thing was they wanted to put it in the bucket with me. And I was in a single bucket rated 350 pounds. And I said, no, you're going to put that in a bag and send it up the pole to me because I'm not going to overweight my bucket. So anyway, the point is, I came down and I said, well, I'm going to have to reach out past my rubber. So give me two more rubber line hose. And the guy on the ground said, no, that's fine. You're okay. And I said, no, you're not in the bucket. I am. So I'm going to cover the line up. So, each job depends on how much, what task you're actually doing as to how much cover. So Jim and I will talk a little bit about some of the things that guys take for granted when working on wood poles that they should be doing, and we certainly should be doing it with the steel poles. On that last slide, one of the things that we were talking about is the system neutral. They put an insulator, tie the system neutral, and then bond it to the pole. So I don't know why they would use an extra insulator on that system neutral and then bond it right to the pole. But anyway,
Tony, there are a
yes.
couple of technical questions, and one of them got answered for a manual about the polyethylene coating. As far as I know, and I see a technical answer there, it says that that polyethylene coating will last forever. as long as the life of the pole is. And I agree with that statement for the poles that we've investigated after we've had them in the ground for a while. About aluminum poles mounted on a galvanized helix. The galvanic series reaction between galvanized and aluminum is very, very, very low. So and actually you improve the life of the galvanized and aluminum by bonding the aluminum to the steel. I know that some engineers, where they are using the grids as a base for the pole, simply use the bolt through as a bonding, but other engineers will say that that bolt through between the aluminum and the galvanized helix are not an electrical connection, because they're strictly mechanical, and so they'll add bonding in between them. I also know that in some environments that the aluminum poles that are run to a ground rod, that they'll use an aluminum electrode lead, aluminum piece of number 4, soft drawn aluminum, over to a galvanized aluminum in order to maintain the same galvanic reaction as you would find between the pole and the two. So you have to decide according to the conductivity of the earth, the presence of the electrolyte that would be there, and also the material compound of the earth itself, to decide or experiment with what reactions that you might get. I know that one of the utilities that we did several hundred changeouts with, that they had scheduled periodic examinations of both ground rods, leads, and pole bases, like every 3 months, 6 months, 9 months, 12 months, just to go back and see how they were, how they would last in the ground. So I think that's probably a good thing to do. Go ahead, Tony.
Hey, Jim. Working the energized environment, like we've said many times already, it's just like working with the wood poles. There's a few differences. We know that the steel is a better conductor than the wood. The steel is lighter than the wood, so it makes it easier to handle. Someone wearing rubber gloves at the bottom of the pole would be less likely to have to hug the pole to maintain control, to get it into the claws of a digger derrick. Where a wooden pole being so heavy, I've seen guys just grab the pole and hug it. So what is your rubber gloves doing? So being lighter makes it easier to maneuver. You always have to make sure that your choker is secure. One of the problems of steel poles is if you use some types of choker, as you go to lift it, the choker will actually slip up the pole. So make sure that the pole choker is not going to slip as you lift it up. Jim's taking his mouse and kind of moving it around the protective cover that the guys are putting on the top. We've always done that with wooden poles. Any crew that I've worked with, doing any safety work, we've always covered the poles up, sticking them up in the Energized line. You see the one picture there of the guy putting line hose on. I do know one occasion where when they put so many line hose on to bring the steel pole up into that Energized area, they didn't realize the amount of weight and sag that was added to it. So when they tested to see where the digger derrick claws would be, they measured it before it was rubbered. So when they put all those line hose on, it actually made it sag, and the digger derrick got up and actually contacted the line hose. It did not trip the circuit out, but it made a little bit of a spark in there. And we had to stop and regroup. What we did was we actually got an extra bucket in there, lifted up on the line, and got it out of the way.
And let's point out
But
here also that the cover up that's being installed, the rubber hose, and you'll see right here they're installing, these are called pole plastics on the pole. They're not designed for intentional contact. So just because they hang rubber on the pole here doesn't mean that when they stick the pole up in the environment, Tony, I'm going to go ahead and advance
go
to the
ahead.
next slide. When they stick the pole up in between the phases, the idea is that you still maintain an airspace and you never come in contact with two. The cover up is there as a secondary protection in case you lose control of the pole, which is kind of tricky to do. And as Tony said, these when we refer to hose, we're referring to rubber, which are they're fairly heavy. They're 5 feet long. They weigh some 9-10 pounds a piece. Sometimes depending on what types they are, and they pull down and lower the sag of the conductor, making this space between the conductor and pole closer, which is what Tony was talking about. There are plastic technologies that are available where they weigh less than 25% of the weight of a hose, that can be used that can do the same thing. But it's important also to know that a lot of linemen will forego the use of plastics because in their experience, they go out and set hundreds of poles just like this, and they grab the pole with the pole grabbers. They have very good control over the pole, and it never comes in contact. And I see this all the time with setting poles without using plastics. We shouldn't be doing that. You absolutely can't do that with these with steel poles. I want to back up to the earlier slide that we had. You see right here, Tony mentioned here this lineman's using class 2 gloves. They're 20,000 volt gloves rated for 18,000 volts exposure. They're setting a pole here in a 15 kV feeder, and that's sort of a relative. It can be anywhere from 12,470 to 15,13.2, anything like that. But we refer to it as 15 kV line. And you can see, remember, our poles are conductive, as Tony showed by the testing that he did on the pole that was in the very first slide. So here he's wearing a pair of 20 kV gloves, setting a pole in a 15 kV circuit. And if that pole comes in contact with the circuit, that pole is going to become energized, and these gloves will protect them. Now, you're going to see later on you see in this slide, we're setting in the conductor. So if we're setting in the conductor and the steel pole comes in contact and the pole becomes energized, and we have to assume that it can be, because you can bang hard enough against these connectors on the hose that they will come apart. Grounding of the pole during setting is an important consideration, because grounding of the pole during setting will ensure that the voltage applied to the pole is going to remain very low. That's the phenomenon that occurs when you ground, is that you collapse the voltage. Current will still flow, but the voltage collapses. And then a voltage would be created between the pole and a gap that occur between the pole and the earth. That's why the lineman wears gloves. So even if you're setting a steel pole in a 115 kV circuit or a 230 kV circuit, those class 2 gloves, even though they're only rated at 20,000 volts, will provide a level of protection if you ground the pole. So grounding the pole is the hard part. If I'm picking up the pole from using a digger derrick or a crane, as the butt of the pole is moving into position, it's kind of hard to put a ground on there, especially if it's a pole that has to be dropped in from above down to the ground. So we found a way to accommodate that as contractors that were setting in here, and that was by using a 2-aught ground. And on the end of the ground, we took a magnet that is available in any hardware store, a good substantial magnet. They're about 2 inches in diameter, that has a steel housing on it with a hole in the center, and we stick a bolt through the hole and we bolt it on the end of a ground cable. As the pole butt comes down to the location where the pole is going to be set, a lineman there with a shotgun holding the cable in the end of the shotgun simply reaches up, and the magnet clamps itself to the pole and thereby grounds the pole. to provide a level of safety for setting the pole in that energized environment. Go ahead, Tony.
I think you said it all. Moving along to the next slide. Thanks, Jim. Jim is one of the foremost grounding experts in the world, I guess. He won't tell you that, but he has taught grounding to a lot of companies, and we're doing more and more grounding. One of the things that gets me is how little line workers actually know about why they're grounding things when they're grounding them. So moving on, we should always follow our prescribed safety procedures when working on steel poles. They vary from utility to utility and one contractor to another. So we should always familiarize ourselves with our company's authorized work practices. And if the work practices are not good, let's incorporate some best practices to go along with that. Through the years, I think we can see where we've kind of deviated from some of the safety practices. Steel poles are making line workers a little more aware of what their hazards are, especially with that second point of contact. So we need to make sure that safety is always number one in whatever job we're doing. But let's not deviate from what our practices are and take shortcuts, because that always gets us in trouble.
And I think Tony will agree with me here. One of the things that we teach I&I, insulation and isolation, and that's what's going on here in this picture on the left-hand side. You'll see all the cover that's there. So I want to talk to some of the linemen that might be out there looking at this, and you say, man, that's an awful lot of cover. Well, this is actually exactly what OSHA intends when it comes to cover up a pole when we're moving these conductors. See, if they're going to untie these conductors and move them around, losing control of this conductor will put it against the arm or against the pole. And that's the purpose of using this cover. There's a couple of things that people will say, well, that takes an awful lot of time. And Tony and I will tell you, as investigators from accidents, that few minutes that you took to cover that arm is a way lot less than the days that you're going to lose if you get that conductor on that arm, especially if somebody gets hurt in doing that. So this is the cover that's supposed to be there. And then I have an issue with safety guys that come out and try to encourage this kind of cover up. And then they say, now, we don't want you to make a Christmas tree, because people say, that's what this looks like with all that pretty orange up there. It looks like a Christmas tree. Yeah, we do. That is what we want you to do. Our experience is the hundreds of investigations we've done, this pays off in the long run. And there's one other thing that you can do here with these steel poles that a lot of linemen don't recognize. You can take these pole plastics that we showed you earlier. We're allowed to cut pole plastics off with a hacksaw or sawzall and make a 2 or 3 foot long section, and that allows us to snap that right onto that pole and provide cover up on these steel poles when we're doing this cover. So I want to encourage you to do that. We need to get out of the mindset of just putting where we think we're going to need it in the process of the work, because we do sometimes lose control of these conductors. And it doesn't matter if it's a wood arm or a fiberglass arm or a steel arm. If you lost control of the conductor, you have no idea what's going to happen. And you simply don't want to be there if it does go to ground. It's just going to make a mess. So we encourage you to do that. Go ahead, Tony.
And when we're working energized, we always have our observing person on the ground, making sure that everything is covered up good. And sometimes in a bucket, you might not see some of those exposed areas. So the qualified observer on the ground could also mention adding some extra cover for you. Like Jim said, putting some of those pole plastics on for any type of inadvertent movement. Our next slide there is covering up, just like in a wood pole. Here they're using a material handler to change out a transformer. The reason I put this picture in here is to show he's got some line hose up on that one phase that he's underneath, and his body, his left elbow, it's hard to see in this picture, is very close to that system neutral. Another misconception by a lot of line workers in our industry is the system neutral is a ground. But what they don't understand or listen to in the training is the system neutral is a current carrying grounded conductor, or hopefully grounded conductor. I have found in my 40 years of experience, some areas that the ground wire is not connected, it's not squeezed together properly. The ground rod at the bottom has been stolen. The ground wire on wooden poles has been stolen, things like that. So we kind of assume that it is grounded, but it is not always grounded. So getting into this situation, we want to make sure that we always cover up that system neutral. And he was evidently in this picture, you could see that he was moving the jib in place to take the transformer off of the bolts. This is our video. I think there we go. All right, here's what I want to do.
They'll be working in this area to rig, block, and tackle for the transformer replacement. So they rubber up all the conductors that will be nearby.
Some rubber goods on. He's in a
line hose
position.
on the wire and blankets over the insulators improve their odds for safety while they're working in the high voltage area.
Is line
the primary lead is disconnected from the cutout and from the transformer's primary bushing.
Up too much.
Once the primary is rubbered up, the line worker rigs the upper block.
So what they're doing
when
here
the sling
is
is secure, the line worker hangs the block so it's positioned above the transformer.
If you don't have a material handler, you use a jib and rope blocks.
The secondary leads are disconnected from the transformer's terminals.
For the non-line workers, what some of the things that we're talking about here, just to make sure you understand. Earlier, we pointed out the 20 kV or Class 2 gloves. So he's wearing Class 2 gloves. It's got a protector on the outside that's required by law that you have a protector over this glove. The gloves gets tested every 3 or 4 months, depending on the utility's decision. He's also wearing rubber sleeves that are rated, they're called Class 2 rated sleeves, 20,000 volts, also 18,000 volts usage tested at 20,000. The gloves overlap them, providing an insulating protection, up his arm. This is the rubber blanket that's used. Rubber blankets also have a rubber blanket that has a split in the side of it to make it easier to wrap around some different pieces of equipment. This is called we refer to it as a clothespin. It's a rubber blanket pin that clamps around. This is that line hose that Tony was talking about earlier. This is a surge arrestor on the transformer. This transformer looks like about like a 15 kVA transformer, 25 kVA transformer. Weighs about 400 to 500 pounds, depending on the core material that's made in there. So I just wanted to point that out for those of you who may not be familiar with the workings of distribution.
Once these leads are disconnected, the only remaining connection is the case ground. The ground is always the last wire to come
Jim,
off.
you can go ahead and stop the video.
The ground keeps the case from becoming hot while the transformer is in.
I think I can't. Whoop. I think it stopped. Whoop. Yeah, there we go.
Yeah, there we go. There we go. I did want to mention that Jeff has a copy of these videos. We just put some little portions in here so you guys could see line workers actually working on the line. So he has those full training videos. If you'd like to contact him, you can certainly get him to send you some. We have several technical colleges that are using these training videos for that. So we should always follow our safe work practices and procedures, working around steel poles. And probably begin incorporating that on the wooden poles because it's the same safety. We've said that over and over. That's the point that we really wanted to make out of this webinar. We should not be treating anything differently. So always familiarize yourself with your company's rules, and you steel guys out there that are selling steel to these utilities from the manufacturer's point of view, let them know about the conductivity and what's going on. And you can always use us as a reference. The last slide here actually has our information so that you can contact us.
Tony, back up to that one slide. I want to point out one thing for both the utility linemen and for the manufacturers here. Let me see if I can get this in. If you see right here, this is a tank ground on the transformer. There's also a tank ground right here. And then right here are the 3 secondary bushings for this transformer. The 2 outside bushings represent the 240 volts. The middle bushing is grounded. That's the neutral. So voltage between the neutral and either of the outsides is 110 volts. This neutral is connected, and you'll see the shadow to it right here, over to the steel pole. There should also be, and it may be on the other side, there should also be a ground connection from this connection here over to the pole. In this case, this is a very important connection that occurs here, and here's why. This is the primary lead for the transformer. So this is going to be a 7,200 volt lead that goes into a coil in the tank, and the other end of that coil is connected to this tank on the other side of that lug right there. If you lose that connection, then the grounding of the tank occurs through the hangers to the pole. On a wood pole, and here's a big benefit for steel poles because we've already seen this. On a wood pole, there's a very high resistance between this mechanical hanger on the bolt into the wood pole. And when you lose this connection, or it vibrates loose, or it breaks, or whatever happens, when that occurs, this bolt becomes very hot and will actually set the pole on fire. In my career, I've done trouble calls and come out and actually find the whole center of the pole burned out and the transformer barely hanging on the bolt. I also did a fatality investigation where a lineman climbing a wood pole to troubleshoot a transformer didn't realize that ground connection was gone. And with that ground connection gone, the case of this transformer had 7,200 volts on it. And when he came in contact with the transformer, as he climbed the wood pole, when he got up there and he reached out to steady himself and he touched the transformer case, and he was killed. The steel poles have an added benefit in that the conductivity of the steel pole is so good that when you lose that ground connection, it doesn't happen often, but it does. If you lose that ground connection, the steel pole almost always assures a ground path connection to ensure that this case will not become energized. So that's one of the big things that I thought of very first thing when we started hanging transformers on steel poles is the integrity of the bonding and grounding connection between this energized apparatus and the steel poles. I thought I'd add that in there as both a sales point for the steel pole manufacturer, and it's also good information for linemen to know about the risk associated with lost ground lead on a transformer on a pole. So as far as, like Tony said, that's the end. If you have any questions, now's a good time to type them in. And me personally, I want to thank you again for allowing us to speak with you and to share and encourage you to get in touch with us. And we'll do what we can to help you answer your questions. Or if you have any doubt, we'll be glad to do that too. Go ahead, Tony.
All right. Thank you, Jim. I'll skip a slide or two. Kind of finish up, just talk a little bit about our basic insulation levels. Of course, they need to be increased slightly for the steel poles. So the basic insulation level is the relative measure of a structure's insulation to withstand over voltage impulses. So we design a system with the insulators to withstand the voltage. Jim mentioned 15 kV, 15,000 volts. It may be 13,000 volts phase to phase. Some systems are 14,000 volts phase to phase. So the insulators are actually rated for a little bit larger voltage. And that's what that basic insulation level does. It allows for an overvoltage, such as a lightning strike or a transmission line maybe falling onto a distribution system. While Jim was talking, I looked into the chat and didn't realize how much lineman slang we were actually using. When you talk about it like this for 40 years, you just assume everybody knows what you're talking about. So we apologize for that. And Jim, thank you for clarifying a lot of the information that I missed. The last slide there is a transmission. Jim Vaughn actually took this picture. He let me know yesterday. I found it in some of our archives, and it's up a hill. So it's a, what do we call this, Jeff? You're going to have to step in now. A weathered pole?
Yeah, that's that core 10.
Core 10,
material, weathered pole.
Yeah,
I'll also add here too. I really liked it. I'd lost this picture. I was glad when Tony found it because I'd forgotten where I put it. This was in Virginia, and it was a really hard pole to get into place. The fact that they were steel poles made it a whole lot easier because of the weight, because this was virtually inaccessible for equipment, and we didn't have the use of a helicopter, and we managed to get everything up there in place using steps and hauling in the poles and setting up a jib in order to get the pole set. There is a question that came from Larry has popped up there about the Helix Foundation with aluminum pole, asking about the redundancy of a ground rod. The purpose of using the ground rod is that the ground rod itself is considered to be an electrical connection to Earth, where the helix or the grid that's installed in the ground being galvanized is actually a mechanical connection to Earth in order to establish the foundation for the pole. So most engineers will agree on the value of testing that galvanized grid itself does not make as good an earthing connection as the ground rod does with the earthing connection. So because typically the grid that gets put in the ground is then replaced by fill dirt, where the ground rod is driven into a native undisturbed dirt, which creates a more intimate electrical connection to Earth. So that's the reason why most engineers, when they design a pole that is set on a grid base, and this is, for those of you who may not understand what this is, there are several different bases or that you can direct bury a pole, you can put a concrete foundation in the pole. Up through the east and central U.S., a lot of steel grids are put in the ground that are made of 1.5-inch, 2-inch, 3-inch, 4-inch angle iron grids. They dig out a very large hole, place the grid in the ground, and then backfill with dirt and sometimes backfill with concrete. But they are considered a mechanical connection. So I agree with those linemen. That grid will do the job and it will put the pole to ground. But because it's considered a mechanical connection, generally engineers will also install a ground rod. The point that I was making earlier is that if the ground rod's copper and the grid is galvanized, that consideration has to be made about the galvanic cell that's created when the copper is placed in the ground, or what kind of electrode to place in the ground to ensure that they don't eat each other up over the next 20 years.
All right. Any other questions? Well, there's our phone numbers, and feel free to give us a call if you have any questions, anything you'd like to ask. Call us if you need some training. We'd be more than happy to stand 6 feet apart and train some of your workers on working with steel poles or grounding or anything in the utility industry. We do it.
And Tony and I are both available by email too. It's a very, very simple email. Jim at ispconline.com and Tony at ispconline.com.
Well, yeah, I was trying to see if your emails were there and they're not. So if you want to type that into the chat function, Jim and Tony, just so everyone can grab those emails, that'd be great. And then I didn't address it in the beginning, but thank you for bringing this up. We are offering professional, what is it called? Engineering credits for professional development. Those certificates will be emailed out with that Dropbox link with the presentations. Mark had asked, or someone had asked if we would have a video. So we are recording this, but at this time we weren't going to include the recording. Mark, if you're interested in it, I'll shoot you an email and we can possibly get you this recording if you're looking to share it. And then looks like I clicked on the screen. So just as a reminder, this webinar series is taking place every Thursday from 11 till noon. And then, like I had said earlier, next week's presentation is Distribution Steel Poles Design and Engineering, presented by Danny Lonergan with Valmont Utilities. So we hope to see you next week. And if you have any additional questions, feel free to reach out to me directly, and hopefully we can get those answered.
We're still on. Thanks, everybody.
Yeah, I'm just going to keep us up for a second because it looks like there's a few typing, but it looks like they're just saying thank you. So appreciate it.